Hello everyone. Today we are going to discuss the second part of the topic, that is the amines and diazonium salts. Here we are going to discuss what is meant by a diazonium salts. The definition of this like this: the organic salts containing a combination of aryl diazonium cation with anions, this A6 equal to Cl minus, Br minus, I minus, NO2 minus, here HSO3 minus and BF3 minus when present, it is known as diazonium salt. Okay, got the definition here? What is the definition? Again I am repeating this. It is the organic salts which contain the combination of aryl diazonium cation with a anion, that is X is equal to what? Cl minus, Br minus or I minus, NO2 minus, HSO3 minus or BF3 minus as a anion. It is known as the diazonium salts. The representation of this diazonium salts is that is here, that is Ar and triple bond N here. Nitrogen carries positive charge here and with a X minus. Okay, now what is meant by these diazonium salts? Here we can have seen its definition. Now we are belonging with the aryl diazonium cation. Here the aryl diazonium cation, it may be regarded as a positively charged Ar plus as a carbocation with nitrogen, Now belonging this to nitrogen, it is a tetravalent. Therefore, the negative charge resides on tetravalent nitrogen due to its tetravalency. Therefore, nitrogen acquires the charge. The representation of like this here, that is aryl diazonium cation is regarded as a positively charged a carbocation, that is a phenyl cation here with a nitrogen, and as the nitrogen is tetravalent, the negative charge resides on tetravalent nitrogen. Therefore, the structure of this is as follows. Here, that is Ar nitrogen triple bond N. Okay, this is on a what? This is a negatively charged here. This is on a electrons here. Okay, here nitrogen due to this, and therefore its structure may be regarded as here as like this. Okay, now the bond nature between aromatic carbocation and nitrogen, and also aryl diazonium ion with a negatively charged species. Okay. Here one main question arises in your mind, that is why diazonium salts are organoionic compounds. Okay, the question is arises in mind. Now what is the answer here? Because of, that is the bond nature between the here aromatic nucleus. Okay, here the positively charged, the carbocation and the nitrogen, in which here what is the bond? That is, it is a covalently bonded. That is the positively charged here carbocation, that is aryl positively charged carbocation is bonded with a nitrogen with a covalently bonded, while the negatively charged species, that is equal to X, it may be attached to this aryl diazonium salt with a ionic linkage. My explanation is that is there is a bond between aryl nucleus and the nitrogen is a covalent one, while the bond between the negatively charged species along with this aryl diazonium positively charged species is a ionic one. That is, as the bond between this aryl nucleus and nitrogen is a covalent, and that of negatively charged and aryl nucleus is a ionic one. Therefore, these diazonium salts are also known as a organoionic compounds. They are also act as a important organic intermediate. Okay, diazonium salts are important organic intermediate. So as far as their preparation is in general is considered, here preparation of diazonium salts is considered. What is the preparation here? Here first, the reaction of aryl primary amine with a that is a nitrous acid, with a nitrous acid. And you very well know the formula for this nitrous acid, that is a HNO2. Okay, here, and aryl primary amine means what? That is ArNH2. Okay, got it here? Now, already here from the HNO2 direct reaction is not possible, because here HNO2 is acts as a source for nitric oxide as a cation, that is of a NO plus here. Now how it is getting? That is a NO plus here the reaction. From this HNO2 here, it can be represented as HOHNO, that is HNO2 here. Okay, that is nitrous acid which is on protonation gives rise to this. What? That is, there is formation of a water with a NO plus. That is nitric oxide cation. Okay, got it here? What I am taking the reaction, that is, first is the reaction of a aryl primary amine with a nitrous acid, and from the nitrous acid we have which we have to count here, that is a nitric oxide cation, which is of a source is a which, that is a nitrous acid. Nitrous acid on protonation we are getting the nitric oxide cation. Now this nitric oxide cation on reaction with this with this what? That is the diazotized product of a aryl diazonium halide with a reaction with this. We get the benzene diazonium chloride here or bromide. Okay, see the reaction first. How we get this product as here? First ArNH2. Okay, here by means of a diazotization reaction. What is the diazotization reaction? That is NaNO2 plus HCl. Okay, here, what is the conversion here? Ar here, N triple bond N here, okay, plus H2. NH2 is converted into a what? Aryl diazonium cation. Okay. Now this is the aryl primary amine. What is the basic reaction here? That is conversion of this primary amine into a this what? That is a what is this? That is equal to this diazotized this cation. Okay, that is NH2 into a N2 and here also a what? That is equal to a Cl minus here. Okay, now how we are getting the Cl here? See this the reaction here. What is the reaction here? That is this reaction is getting here that is ArNH2. So here ArNH2 here on the reaction of this which that is a nitric oxide here. Okay, this is called as a positive charge here. Thus there is formation of ArNH2 and double bond O here. Okay. Positively charged here. Now here from getting this what? That is minus H2O here. Okay, H2 and O here. There is formation of Ar and triple bond N. Okay, and this is called as that is the aryl diazonium cation. Okay. Now whatever may be the aryl diazonium cation is getting from this, that is the source of a which? That is a nitric oxide cation here. Okay. Now what is the next reaction here? That is the attack of this which a Cl minus. That is second reaction. That is Ar and triple bond N here plus Cl minus. There is formation of Ar and triple bond N here. Okay, and Cl. That is aryl diazonium chloride. This is the general method of the formation of a which that is the diazotized salt here. Now we are going to discuss here the first point, that is the nomenclature. For the nomenclature here, or diazonium salts here. Okay, I am giving you to first the examples and simply you can write this the name of the diazonium salts examples. Okay, now first example is that is this is the example here. See it carefully that is benzene here. I am drawing the ring. That is Cl here. Okay, including the name of this. That is then next Okay. Now, azo means what? That is N triple bond N. Okay. You can write the simple type of reaction. This is what? That is the arene. In simple sense, it is what? A benzene. Therefore, name of this compound is benzene. How many times this nitrogen is present? 2 times. Therefore, we have to use the words instead of this N triple bond N, that is the diazo. Benzene diazonium chloride. Okay. Now, the second example is what? That is the benzene ring in which the CH3 group is attached. And excluding this part, when we are going to see this part, what is this? That is the toluene. Okay. Now, in which position here? Para position. Therefore, you have to must put it out the position. Para toluene, benzene, diazonium. Instead of benzene, you can, there is no need. Para toluene, diazonium chloride. Diazonium chloride. Okay. Here, what is it? Next here, instead of just you have to look out the structure of that particular compound. And what is the structure? Identify it. Just write down the diazonium chloride here. I am going to give you the next examples. See here. Second is, that is okay. Here N triple bond here, that is the N here, Cl here. Instead of Cl, we have to take the another compound here. Second compound is what? That is given to you. That is this type of compound here. That is N triple bond N here. Okay. The positive charge, negative charge, and here also a bromine, not a BF3 here. Okay. Okay. Now for these two compounds, how are the names are considered? First, you have to just identify this group. What is this group? That is the nitro. Which position it has located here? Para position. Therefore, for considering this, you have to write here para nitro. Okay. What is this here? From the right portion of this here, that is benzene. Para nitro, benzene, diazonium. Which group is situated in the last as a negative part here? That is a cyanide or nitrite. You can use any of them. Okay. What is this? That is para nitro, benzene, diazonium, nitrite. Now again on this, that is here, what is this? That is, you are also considering this as a phenol also, and also considering as a para hydroxy also. The better way is what? That is, it is considered as a para hydroxy. Okay, here, therefore para hydroxy, benzene, diazonium. Okay, and now what is the name for this BF3? That is fluoroborate. Fluoroborate. Okay, in this way you can name the number of diazonium salts here. Okay, now the next part is what? That is the preparation of this benzene diazonium salts. Okay, see here. Actual preparation of benzene diazonium chloride. Okay. Now, in this preparation, also we have seen in thorough in the for a while minutes here. That is here. What is the reaction of formation of a benzene diazonium chloride here, that is reacting aryl diazonium salts with nitrous acid at temperature 273 to 283 278 kJ, because we have to maintain, first point is that is temperature should be a important one. When the temperature exceeds, what happens? When temperature is higher than 278, the violence and decomposition of benzene diazonium salts. Diazonium salts. So first of all, we have to just keep the temperature is as low as possible. Here, first reaction is that is the diazoxide reaction for the conversion of a primary amino group into a N2Cl group. The reaction is NaNO2 plus HCl, why is HCl here? Okay, or HCl only. There is formation of a NaCl plus HNO2. Okay, now HNO2 is called as a nitrous acid, which is a source of a nitric oxide cation also. Okay, now see here. Now in this reaction we have to take here, we have to take first HCl as a which molar, that is equal to 3 molar solution. Okay, and aqueous solution of this NaNO2. Okay, here what is here? Now whatever may be the reaction is proceed, then we get the HNO2. Now from HNO2, what is the reaction? Plus H plus gives rise to this motion of H2O here. Okay, plus NO plus. Okay, now this nitrogen ions gets attacked on this, what? That is the benzene diazonium cation. Okay, before this we have to convert this as a, take here as, that is in the sequence like this. Para amino NH2HCl here. For this sake of simplicity, we can write here as simply here as like this, that is benzene diazonium, and that is a aniline here with its HCl form, that is a aniline with its hydrochloride form here. Temperature is maintained is 273 to 278. Okay, here what is the conversion here? That is, see this NH2Cl gets converted into this N2Cl. Here N2Cl. Okay. That is benzene plus on HNO2 here, plus 2H2O here, diazonium chloride. Okay, got this preparation here, that is from the aniline. First we have to carry out the diazotization reaction here. whatever may be the source of nitrous acid, we have to take it in with a aniline at keeping the temperature to 73 to 278 Kelvin. There is formation of benzene diazonium chloride. But one specialty of this reaction of this benzene diazonium chloride is that, see here, limitations of this, limitations and precautions. Okay, plus benzene diazonium chloride is decomposing at temperature above 278 Kelvin. 70 Kelvin. Therefore, always it can be used in solution form. Okay. As the formation of a benzene diazonium chloride, the reaction is exothermic one. Keep the temperature as possible. Keep the temperature as low as possible. And third point is that is the completion of a reaction can be tested by completion reaction tested by using adding reaction mixture to the mixture of Ki and starch. Ki and starch. And what is the indications here there? If the mixture we have to add here, this reaction mixture to a mixture of a Ki and starch, if there is appearance of a blue color, here, appearance of blue color indicates the completion of a reaction. Okay. First point is that benzene diazonium chloride is decomposing at temperatures above 278 here. Therefore, it can be used in solution form here. Second, the reaction is exothermic one. Therefore, keep the temperature as low as possible here. Third is the completion of a reaction can be tested by adding the reaction mixture dropwise to the mixture of Ki and starch. If you are getting the blue color or blue purity of the solution, it indicates that the reaction gets completed. Okay. Thus, we have here completed and are discussed here first diazonium salts, their nature, their IUPAC nomenclature and its method of preparation. Okay. If you have any doubts, please ask me in groups. I hope that you like my video very well. Please subscribe the video to get the next video in earlier conditions. In the next video, we are going to discuss the reactions of diazonium salts. Okay. Thank you.